Hey, welcome back to another episode of LokadTV. Businesses are often run on the ethos that customer is king. However, with software companies, this is not always the best route to follow. Today, we're going to be tackling the subject of software Frankensteinisation. So Johannes, this is a topic that's fairly difficult to pronounce, so I'm going to probably leave this one to you. I'm assuming we're not talking about a big green monster today. So what is it we're exactly talking about?
So we are talking of a process that is driving the evolution of software, and more specifically of B2B software, and even more specifically of supply chain software. But it mostly applies to long-lived B2B software. So what is this process, and why do I refer it as Frankensteinisation? It's a process in which, over the years, the software evolved with the ongoing stream of large deals that are negotiated between the software vendors and its clients. And the interesting thing is that that's where the Frankensteinization part comes from, is that every large deal that is negotiated between the vendor and one of its large clients is going to most likely leave a scar in the software. You know, and it's a gradual process where you negotiate with a large company. The large company has demands, and in order to cope with those demands, there are adjustments that are being made to the software that are not exactly fitting in the overall architecture, in the overall philosophy, in the original design. And so the feature gets there, but in a slightly, I would say, hackish way, and that's a scar. And the problem is that if you repeat that, you know, over and over and over for years, then what you end up with, I would say, in terms of software, is, is a Frankenstein monster. You know, it's a beast made of tons of scars that looks like a bit hideous and super composite and overall very weird. And that's how you end up with those Frankenstein software. And I believe it's something that is happening in most B2B software, but in supply chain software, it's like on steroid.
Okay, so let's talk about these scars then, as you refer to them. I mean, what do they actually kind of look like? Because I mean, surely they're improving the software and they're adding extra features. Is that such a bad thing?
Yes, I mean, obviously, that's a trade-off. You want to improve your software, yes, but the software is it's a very complicated object, a piece of software, and it's not exactly. I mean, the analogy falls apart. It's not exactly like a building where you could say, "Oh, I'm just going to add another floor, another floor, another floor," or I can just nicely expand. It comes with lots of invariants, lot of, I would say, design assumptions, and it's because those assumptions were made very early on that the software has some integrity, architectural integrity. It can take many forms. For example, there are many ERPs that were built around the ideas that if you want to capture seasonality, you're going to use seasonality profiles that are exactly 52 weeks that represent, you know, your seasonality profile for a given year, and that's going to be 52 weeks. So it can work relatively nicely to reflect, you know, seasonality profile with those fixed size vectors. So you literally have a table with 52 columns that represent one column per week, and you have all those seasonality profile that you can nicely apply to any kind of item that you're producing or selling. But what if suddenly you want to model, let's say, Chinese New Year? You know, it doesn't fit into this 52 weeks grid because it's going to move from one year to the next. It's the Chinese calendar, not the traditional Chinese calendar, not the Gregorian calendar. And you will face similar problems with Ramadan or even Easter. So you see, you had this very nice assumption that can fall apart when you face a demand that do not fit into your framework, and that can take many forms. But the process is you're willing to accept something, and the problem is that you don't necessarily, as a software vendor, you don't necessarily have the time to rewrite your entire software stack so that this new features makes its way into your architecture in a way that is completely native. So in the end, it's a bit hackish. Also, it's a deal. I mean, you're negotiating with an important client, so you don't have like years to close the deal. So it has, and then you don't have years to deliver the feature either. So you see, things have to be done in a relative emergency every single time, just due to the fact that it's actually a business negotiation to close a sale. So, so things are rushed almost by design.
Okay, so but when does something become a scar and when does something become a good feature? Because all these softwares have got to evolve, they've got to change, they've got to work for their clients. So what kind of differentiates the two? How do you know that something you're developing isn't going to become a scar?
So the question is, how much will it cost in terms of maintenance? I mean, maintenance, every single line of code that exists in your big enterprise software is something that you will have to maintain. And one thing that people do not always realize, I mean, even software professionals do not even realize, is that you see, because the software is like intricate machinery where every single part tends to interact somehow with all the other parts, you have like a quadratic complexity problem. I mean, if you have like very careful engineering, you can avoid that, but mostly you have that. So what does that mean? It means that if I have 10 parts, then I have basically about 100 potential interaction, 10 multiplied by 10. If I have 1,000 parts and they are all interacting, then I have 1,000 multiplied by 1,000. And every potential interaction is a recipe for all sorts of problems: security issues, bugs, crashes, incorrect results of various flavor, or just massive slowdown of the software. So bottom line is, when you add more parts, you go from 10 to 1,000. But if you had 10 parts, you had like 100 interaction. If you have like 1,000 parts, you have 1,000,000. So you see, it does not scale linearly at all. It increases the number of potential interaction between the parts in your software increase much more rapidly than the number of parts. And when I say parts, you can think of features, capabilities, screens, data options for entries or whatnot. So the bottom line is that if you have very, very careful architecture, what do you mean by very careful software architecture? Basically, it means preserving, I would say, the number of interaction between your parts, your features, etc., to keep that, I would say, under control, so that when you double the number of features that you have in your software, you don't multiply the number of interaction by 4, 2 times 2, 4. So that if you double the number of features, you only double the amount of maintenance that you will need to make. But it's very difficult, and when it's rushed, when you double the number of features, you actually multiply by 4 or even more the amount of effort that you have to invest in maintenance. And so, back to your initial question, over time, what does that mean? It means that maintenance costs skyrockets, that your capacity to actually roll out new stuff gets lower and lower. And then whenever you introduce a new features, it triggers like an entire wave of incompatibilities and bizarre unintended interaction between different parts, because again, it has not been completely thought through. And so, and that's something that's where the pain increases over time.
Okay, so let's think of things from that software company's perspective. How can they introduce these new features? How can they implement these features to keep their clients happy without introducing this extra layer of complexity? What can they do?
I mean, I think the lesson comes from the world of B2C software. Google do not roll out new features for Google search, or Netflix do not roll out new features for Netflix just because they are signing up a new client. They don't take a new client, start discussing with this client, say, oh, all those ideas, if we don't have those features, then you will not sign up with us, so we need to do it like now. They don't work like that. They think of what is the domain, what is the specific problem I'm trying to solve. I will try to have like the very high perspective on this problem, and then think through, I would say, an approach that is going to generate tons of of solutions, of capabilities. So typically you don't want to solve one micro problem. You want to say, I want to solve an entire category of problems. And so I need to re-architecture my software to address this a spectrum that is relatively large of problems that are relatively similar. So, and again, this is happening like all the time. You know, you discuss with your client, you listen, but you listen to the problem, not to their suggested solution. If you, in comparison, you see, when I go to the B2B world, what is happening is that typically the customer do not come just with a problem. They also come with a solution that may or may not fit your existing software stack, and it may not fit the future variant of this very problem that they have.
So you mentioned there sort of like the big companies like your Googles and your Netflix. So what you're basically saying there is they're not really listening.
Yes,
what about those annoying like pop-ups that pop up every day and you can send feedback back to these companies? Is anyone actually looking at these?
So, I mean, first, the pop-ups are typically sort of, I would say features that are undesirable. But to be, I mean, to the credit of companies like Google and whatnot, they are the pop-ups where you have to say I comply with the terms or whatever. They have it was not their choice. Those particular features, they're not exactly features, were forced upon them with regulatory constraints. So the law has been made so that they have to do that, even if it's a very, very bad idea. So they have to comply, so they end up with like a bizarre feature. But again, that's a bizarre feature that was not of their own making. It was like imposed on them. And if you see who did win, you know, the web, it was not people who had like super annoying ads. It was more like the people like Google who had very clean ads, you know, isolated on the side of the page. So they were thinking of their customers instead of just, you know, destroying the value of their product because they have something that is so annoying. So they can really think it through. But really, more importantly, they take the time to think their feature through, as opposed to the process where you have like a B2B software company, especially in supply chain where you have so much diversity. So you have literally hundreds of situations, scenarios, contexts, and where typically at the closing time, people at the last minute negotiate tons of features that I would say invariably, not always, but almost always, turn out to be bad ideas 6 months later. And thus, because they are bad ideas, they are not necessarily used further, but you will see bits of software that remain in the software forever.
Okay, so we're going to agree that software Frankensteinisation is a bad thing. What have you done differently at Lokad? Because we still sort of are adapting to the needs of our clients. You've got to keep your clients happy. So what have you done differently at Lokad to kind of avoid this problem?
So during the first couple of years at Lokad, we were facing this very problem. And it was very tough because it was a trade-off like you want to do it right. It takes like 1 or 2 years and it's way too slow. You're not doing it right. It can take like a couple of weeks or a couple of months. Then you can close the deal, but then you have a big problem because you have this big scar that is like a ugly hack. You're basically accumulating technological debt. So for the first couple of years of Lokad, we didn't have, I would say, a solution, but we got increasingly exposed to the very problem. And although we were a startup, you know, the technological debt was increasing. And it was a very, very bad situation. And that was a point of time where I realized how, you know, the trend was not good and how you can, if you think like 2 decades down the road, you say, because at the time I was seeing like competitors who were having like massive bloatware, I mean software to do like supply chain optimization that were so degenerate in the number of features that they have and the fact that there was no consistency, and say, how can you produce something that is so bad? And the answer is one bad feature at a time. And if you do that for 20 years, then you end up with a monster. So I realized, you know, that it was not that those folks were like idiots or incompetent or whatever. It was just that they were actually doing a fairly good job incrementally of doing their best to basically win one client at a time. But the problem is that they were like scouring the software one client at a time. And if you do that for decades, the end result is very, very bad. So we decided to take a completely different angle. And that was actually the birth of Envision. So Envision is our domain-specific programming language. And the idea is that in Lokad, we did completely split all the problems that were like the infrastructure. So that was basically the design of Envision, this domain-specific programming language. It's big data infrastructure, it's machine learning infrastructure, which was going to be like a very long-lived product that you want to maintain and upgrade, but it's like a multi-year effort every time you want to change and upgrade that. And separately to have like for every single client a completely bespoke implementation that is written in scripts that happen to be Envision. And because Envision is a domain-specific script designed for supply chain optimization, we could write something that is completely custom for every single client, I would say with very, very high productivity, while making it completely bespoke. So you see, we start with a blank sheet, we customize it completely, and then we don't have to face the situation where the client asks us for something that we do not really support, because on the Envision side, we have programmatic capabilities. So if we have to do something very special for a client, well, the worst case is the script that we are going to write for this client is going to be not as nice and compact as most of the scripts that we usually write, where we benefit from an infrastructure that has been completely designed to make it easy to solve certain class of problems. So you see, the idea is that if you introduce advanced programmatic domain-specific capabilities into your platform, then suddenly you don't have anymore to rush a negotiation where you're going to scar your product. You can actually do the customization in your programmatic environment that is like bespoke for every single client, and then keep rolling your upgrades for your platform, I would say, with your own schedule that will most likely not match the schedule of your clients.
Okay, so it sounds like you kind of identified this quite early on. Let's talk about those software companies that are experiencing this kind of bloatware. I mean, is there anything that they can do? I mean, should they start removing some of these features to simplify things? I mean, have you got any tips for them?
I mean, so the situation is depends whether first, you know, your large company, you have the software that run, let's say, your supply chain, that can be your WMS, your ERP, your MRP, and this sort of things. You may, as a company, you may not even have access to the software itself. It might be just a vendor product. If you do not have any access to the product, then, well, you're stuck with the complexity of the piece of software that you just acquired. If you have access to the software and you want to simplify it, then indeed you should start by just looking at all the things that you're not using and aggressively discarding them, removing them. I mean, most people are typically worried when they think of just removing parts of an existing piece of software, because they think, oh, what if we lose X and Y and whatnot? Yes, true, you can lose. If you remove capabilities, you lose those capabilities. But if you remove something that is almost never used, you can also remove entire classes of problems that was resulting by the very presence of this tiny feature. And it's very frequent that we see at Lokad ERP implementations with literally thousands of tables. You know, you have literally, so you have one ERP and let's say 5,000 tables. Each table can have anywhere from 10 to 200 fields. So it's like massive complexity. And even to back up the ERP, it's so complicated because you have so many tables. You need like a table to store the list of the tables and whatnot. So that's That's the sort of situation where if you can identify that you have tons of tables that are not even used anymore, that you have screens that are not even used anymore, by just removing them, suddenly you simplify everything. Because, for example, if you have to upgrade from one version of your database to another version of your database, the sort of problems that you can face is that you need to upgrade, pieces of logic that are not even used by anyone. Again, I say every single line of code, or that can be, Java, C# or SQL or whatnot, that exists is a task that you need to maintain pretty much for as long as the line of code exists. So if you remove that, it means during your next integration, your next migration, people will not have to ask the question of how do we migrate this thing to the next version of the system or to the next system altogether if you want to migrate altogether. So, and that means that I would say for, let's say, supply chain executive who need to think of the supply chain software, they should really think of a parsimony principle. If you don't really need it, you probably it's better not to even have that part of the system. It will just be a burden and be very, I would say, to constantly pay attention to the technological mass of the solution that you're actually acquiring and operating. This technological mass does not come free. If you have more screens, you will need more people to train them. So if you can remove a couple of screens, that would mean less trainings. There will be less bugs being reported, less fights with IT and everything. So yeah, all in all, I would say it's about managing the complexity of the IT. But the tricky part is that typically IT has no clue about that. Why? Because they do not have access to the business value. So you see, they cannot differentiate between features that are really necessary from features that are not absolutely necessary. For example, just because they are not supply chain, so they can't translate tables, fields, screens, or capabilities into euros or dollars. That's the sort of things that only, let's say, people on supply chain or marketing, if you're looking at different systems, can do. And that's why IT need the backup of those people who are like typical decision maker in the company to drive the prioritization and the change and the overall simplification of the system.
Okay, so to sort of wrap things up, you mentioned there the supply chain executives. If I'm a supply chain executive that wants to invest in some new software for my company, sounds like I shouldn't really be asking for that much customization because that introduces problems. So what should I be looking for?
Yes, I mean, asking for customization or special feature is like a recipe to to generate problems. So if your software vendor didn't have enough problem of its own, you're just creating new problems that will just make it worse. So really, you should not do that. As a suggestion is, when you can actually ask for customization and just as a test, Why? Because if the vendor accepts, willingly engage in the discussion with you with the customization, it means that the vendor has no integrity. That means that the vendor does that with every single other guy, which means that even if the product is good today, in 5 years from now, it will be a nightmare. So first would be, if you ask for customization, it's good to ask, and you should really expect that this request should be denied. If not, then that's a problem. Then, what is really the smart thing that you can ask? The very smart thing that you should ask is not to have special features or whatnot. If you have to ask for one thing, is probably an access to the CTO or the product manager, on the vendor side, and just part of the contract probably ask like, I want to have a meeting with this person like 2 hours once a month or something. Why? Because if you negotiate to have like direct access to the people who are basically engineering the roadmap of the vendor, then and you can just present your changes. You don't need to force your solution that you think of on them. You just need to present your problem, and then that's just engineer. That in front of you, you will be talking to engineers. If you talk about you present problems to engineers, what do? They start working on the solution of the problem. So if you just have like a routine meeting where you just happen to present your problems, then you don't need to have in the contract any negotiation for any specific features to emerge. You know that give or take, a couple of years, features will start to appear in the product that magically happen to fit the very problem that you've exposed. Why? Because again, just do the math. The CTO of a software company, how many meetings can this person have with clients, in a given month? And I would say usually they have like max 20. So if you have one meeting a month, then you basically get pretty much automatically like 5% of the mental bandwidth of the CTO who is driving the technological development of your vendor that you're trying to acquire, so that basically it's fitting your own very problem. So my suggestion is really, if you want to play it smart, is you want to get close to the people who have the control on the roadmap. It's much smarter than to negotiate hastily a broken feature that you're going to ditch in 6 months from now because you will realize that your solution was not that good, that your problem changed and whatnot. And also another thing is a completely different class of advice would be, if you want to avoid software Frankensteinization, is you want to think of a piece of software that does one thing and do it well, as opposed to have like the monster that is supposed to have like super extensive capabilities, that is supposed to do kind of everything, but then in the end does everything kind of badly. Again, it's much easier to improve a tightly focused piece of software than a mega gigantic framework that is doing everything, where whenever you're going to touch something, again, think of it as the quadratic number of interaction. You have 1,000 features. If you had one, you need to think of all the interaction with the other pre-existing 1,000 features. So it's like the tax, to introduce one feature, is to look at all the 1,000 interaction. If you have only 10 features and you add 1/11th, it's only 10 interaction to review. So it's, again, focus on something that is very lean and sharply focused on the very problem you're trying to solve.
Okay, great. Well, I'm afraid we're going to have to leave it there for today, but I'm guessing there's a few CTOs out there who might not thank you too much for that, because they're getting a few more phone calls now.
Thank you, Kieran.
So that's everything for this week. We'll be back again next week with another episode, but until then, take care.